Hello, everyone. Thank you for coming. And my name is Claude. I'm a video artist from the Korea, and I'm today's instructor of TDSW workshop. So today's topic is abstract fluid simulation and Notch basics. So we will learn about the basic interface of Notch and proceed with fluid simulation using a particle system. And I will explain how to use Notch in media server programs like TouchDesigner and D3. So the content of today's workshop was level basic. So it will show a new way of working in real time for those who are learning about the Notch for the first time. So let's see a brief presentation and move on to an example file. Let me explain about the Notch, like what is Notch? Yeah. It's a real-time visual programming software that is really widely used in contents such as performances, interactive exhibitions, and virtual productions such as XR. So you can see really good stuff made in Notch with addresses here, www.notch.1/made-with-Notch. Yeah, you can see many productions in AR or XR or exhibitions and the performances. Yeah, so I'm gonna explain these are advantages of the Notch. So Notch is rendered on the GPU in real time, so the operation is really fast, and we can build really fast in work environments, and it's really easy to get started with node-based programming, and easy to use the operate media server programming, and the visual quality using features such as particles and ray tracing procedural fields, which is really cool. And these are downside of the software is that the license price is a bit high. So we can click this. Yeah, we can see the pricing of Notch in this address, www.notch.1/pricing. Yeah, Notch has two different type of the license called Notch Builder and Notch Playback. Yeah, we're gonna use the Notch Builder, and license prices like this. Yeah, so subscription system and playback license about right here. So we can pay by a weeks, or the depends on the resolution. Yeah, and the hardware specs are very high. The official website recommends RTX 2080 Ti or higher. Yeah, these are scores of the graphic cards, GPU. So yes, and also it's not easy to manage signals such as like OSC and MIDI signal. But even considering these shortcomings, I can assure you that it's worth using because it has huge advantages. And I will recommend the artists and tutorial site that you can refer to. The tutorial is the best on the YouTube channel, official YouTube channel. So you can get a really lot of information and about the Notch here and get used to the Notch system very quickly. And Armin has really great tips, and his breakdown videos are really cool. Yeah, you should check about these videos. And yeah, these are who are artists who use the Notch software. So Brad Bolton has a really cool stuff made with Notch like this. He built a audiovisual, live, and interactive systems with Notch. Yeah, and Matt has really great stuffs in. You should check his Instagram. Yeah, so today's example files can be downloaded from the driver link shared by TDSW. You can see on the YouTube live. The link is here. And yeah, if you have any questions, please feel free to send an email to contact@cloudeworks.com. So now we are move on to example file, and let's learn the notes. Yeah, when we open the notes the first time, we can see this listen file template samples window. So I'm just click the blank project to create new project. And second, the layer setting is coming, so we can set the layer name in here, like articles and notch basics. And we can set a timeline in here, and properties we can adjust later in the root node. So we just press the OK button to create a new project. And first, let me show you the finished visuals. Yeah, first I will explain the interfaces and particles. And second, I will explain about the fluid system with the particles and procedure. And last one is the main topic. Yeah, explain an abstract like fluid simulation and combine with light tracing. So back to new project, and now let's briefly explain the interface. This screen is a render window showing the final output, so we can check about the final output in here. And there are the tab where you can search for nodes in here. And this window called a node graph, so we can create some nodes and create a system with some nodes. So this window is called the properties window. We can specify the setting values for each node. Yeah, and when we create the project, the most important thing in the initial setting is our project resolutions and frame rate. So you can set the resolution in here, project, setting, and rendering. So now we can see the default resolution in HD size. Yeah, I put width and I put height. Yeah, we're just gonna set this default mode, and frame rate set. You can see this pink button. We'll call it time properties. So you can set our frame rate limits and minimum frame rates and maximum frame rate. We're gonna set about 60 FPS and press the OK button. Yeah, and now let's add some node to make our particle. Yeah, node system is such that everything must be connected to root node of the node logo here in center, and to be displayed on the render screen. And particles, fields, and procedural system have their own roots, so you can control the shape and movement of their creation in detail. So in case of the particles, we have 4 components: effector, emitters, rendering, and shading. So you can configure the particle system by adding each node and then connecting it to the particle LUT. So effectors control movement. It has functions such as creating dimensionally or providing physical simulation. And emitters, you can set the shape from which particles will be created and set the numbers of particles or particle life. And rendering, rendering can set the particle shape. It has various rendering settings such as point sprite, 3D shaped particles, trails, and more. Last one is shading. Shading has the ability to change the color and texture of particles by time, position, or lengthiness. So shading is not essential for the particle system. I was explained about the 4 components of the particle system, and I will add a particle LUT to create the particle system. If we want to bring the particle LUT in node grab, you can either double click this or drag and drop to the node grab in here. And we have to connect this on the LUT node, so we can drag this from the LUT node and to the particle LUT input. Yes, input is here and output is here. Or we can just press then Control R on the keyboard to, So it will automatically connect to the parent node. So particle LUT is a collection of global settings such as particle speed and particle count limits, master size, and more. So now let's add an emitter and rendering node. So we're gonna use the primate emitter and point renderer in here. You can double click it or drag to the node grab in here. Oh, if you want to delete this any node, we have to press the delete button. If we press the backspace button, it will never get deleted. So we have to delete button in here. In case of the primate emitter, you can create a 3D object-based particle composition that Notch provides by default, and point renderer creates a particle shape in the form of the point sprite. So it will not be affected by lighting or cast shadows. Instead, the load on the hardware is very low. So we have to connect with the particle LUT. These are the emitter and rendering. So we have to drag from the particle LUT to the emitter or point renderer, or we just can press the Control R on the keyboard to connection with the particle LUT. The first thing to set the setting for the best particle count in the primate emitter, which is here. The max particle count is setting the value that allows distribution of how many particles will be generated for each emitters, and when there are multiple emitters through the dumb particles in particle LUT. You can see dumb particles in here. So we can set the max limit particles in here, and each particle counts are over here. So if you set 64,000 particles in the particle LUT, and you can fill one emitter up to 64,000. or divide two emitters by 32,000 each, like this. Sorry, 2,000 and 2,000 like this. Yeah, but I will just use a one emitter for the fill 64,000 in here. So if some of max particle counts in multiply emitters exceed known particles in the particle loops, an error will be occur. So it's really important to distribute the number of particles well. So if I press the space button to play this, we can see the particles are explode. And I'm going to add a factor. Let's add a turbulence factor in right here. Yeah, again, same thing. Yeah, double click it or drag to the node graph in here, and Control R or the drag to the turbulence factor in here. Yeah, this effector I'll note that scatters the direction of the particles into turbulence like noise or turbulent. And in the point renderer, you can adjust the particle size over here or particle alpha over here, randomness, and more. And since there are many particles that overlap, so I will reduce the alpha and size like this. Yeah, I think it looks really cool. And so I will explain about the properties of the turbulence factor. So you can think of the velocity amount as a intensity of the turbulence and the radius as the range that this turbulence reaches. So this radius can increase the quality of the visuals by adding an effector only partition when you are working on the interactive work or detailed video or later. And by noise scale, I mean the interval of turbulence. So as it gets closer to 0, so you can see the flows in the almost in one direction. And as it gets closer to 1, the period narrows and you can just see the scatters or move various directions. Yeah, the most important thing about the properties is that the value is not limited about this. In case of this and the 1, not limited to 1. We can change it to higher number if we typed. So I'm going to increase this noise scale to about 5. Yeah, I think it looked much better quality than when it numbers in 1. So the particles, I think, are too far away. So I just adjust the zoom. Yeah, if you drag the mouse in here, we can zoom is adjust like this. And we can rotate the camera also be adjust in here. Yeah, it looks cool. And this time, let's add a parameter of the factor. Yeah, this factor is a 3D object provided by nodes that can make particles scatter or scatter. I slightly adjust the velocity and weight to make it protrude a little more than a spear shape, like this. Yeah, I think it looks fine now. And let's add a trail lender over here, trail lender, and connect with the particle system, particle loops, drag it to here. So we can say the trail lender is exposed. So I think this, yeah, my mic doesn't work well. Sorry. Yeah. I think the alpha value is too high, so I will lower it a bit like this. And adjust the zoom and rotate the camera right here. Yeah, it looks fine. So we will add a feedback, frame feedback actually in the post FX create after images. So the first FX blur and frame feedback is right here. So can grab this node graph and connect with the root node. And let's adjust the previous frame frag value. Yeah, that's cool. And not only does this feedback live on after image, I can also cast grow images or the shape or rotate like this. So we can adjust the feedback scale X. It can grow on the X axis or Y axis, and we can the feedback the rotate like this. Yes, so natural particle system works as it now. So by controlling the properties or of the effector, emitter, and rendering in detail, you can create high quality visuals with a small number of nodes in real time. So let's finish the first example by showing the basic system like this. And now we are create a new layer and explain to procedure and pull the system. Yeah, the setting for the new layer in here, file, new layer, or you just press the Control Shift N of the keyboard. So this time we will turn on the what called default rendering. You must turn on this to proceed with the setting for the lighting and cast shadows. So as with the previous layer, I'll just press the OK button. As with a previous layer, create a particle load and connecting the load node. And I'm gonna add a parameter emitter right here and connect to particle load. And this time we will create a 3D-based particle. So just adding a mesh renderer in here and connect to particle loads. Yeah, in case of the mesh renderer, it's not possible to use it alone. You can add the node called the shape 3D. And we can just search shape 3D over right here and grab this and connect it with the mesh renderer like this. Mesh renderer up to shape 3D's input. Yeah. And when I press the space button to play, but now the particles are not visible because there is no light node. So we'll add something called box icon lighting. Yeah, this box icon lighting and connect it to the load node, and we will add a bounding box to the bottom input of the box icon lighting. So bounding box here and connect the bounding box up to box icon lighting's bottom inputs in here. So the size of the box shadows are automatically created according to the distance between the positions about the objects. So light must be enabled when the default rendering is enabled. Yeah, so we can see the mesh renderer like this. And I'm going to explain about the fluid simulation with the particle system. There's our all in the factors. So there are 3 fluid simulations in the particle effector. There are colloid fluid and fluid flip and SPH effector. First, let's add a colloid fluid effector and connect with this. As you can see, we can see that it makes particles move like the fluid form of the straight noise. So just like when using turbulence, the spacing can adjust through the noise scale. I think this noise scale is too big now, so I will adjust it like this. And I have to adjust the particle size in the mesh renderer in here. Yeah, I think this seems appropriate. So colloid shows like this, and I'm going to explain about the fluid flip effector right here and connect to particle loot. Yeah, this effector is an effector that simulates in the real fluid dynamics and shows the real fluid properties. It has useful functions to express floating forms such as smoke or gas. So there are 2 main types about the server mode. So fluid flip and PIC system. Yeah, these are the called fluid in particle and particle in cell. So in the case of the flame effects, although it's less detailed, it can be operated stably. And the PIC system, it's really detailed but shows a noisy and fast simulation. In addition, it's possible to control the speed through the velocity and simulate the speed or properties, and detailed fluid simulation control is possible through the surface tension and depth spread. So I will use this fluid flip combined with the colloid fluid simulation. Yeah. So if this is your first time to see a fully defined factor, you might think about this just speeding up. So when I'm explaining this function, I usually explain this setting with the collision effectors. So let's add the primitive collision effector right here. Yeah, this effector makes the particles collide in a simple 3D shape. Normally, you can just stay there or they create a limit for the position after the collision. But if you are use the fluid flap effector, can even simulate bouncing after the collision. So I'm going to try using an inverted by activating inverted in a box shape. And trying to rotate the camera in here. Yeah, so as you can see, the particles collide and bounce off the box shape. So very realistic fluid motion can be created with this fluid flap effector. Yeah, and last one is SPH effector. I'm gonna delete this and this. And we have to enable selected or yeah. Oh, actually I have to disable selected like this, or we can just press the Ctrl H to disable and to right click and enable selected, or you can just press the Ctrl Shift H to enable selected. So now I'm gonna disable this factor and I'm gonna connect with the speech and the particulate. So SPH means smooth particle hydrodynamics, which is very good a factor for the simulation, the requests, and fluid system. And based on the motion and real requests, you can create a realistic requests with many properties such as gravity, buoyancy, and surface tension. So this factor also look effective when used with a collision. So I will use the primitive collision later and just play button like this. Yeah, you can see the particles fall down under gravity, and if we get enable selected, then the particles and the liquid splashes as I collided. So the first of this liquid can be adjusted in damping and if you say that the falling speed is slow, you can increase the gravity value. So I'm going to adjust the cell size and gravity right here. And I think primitive emitter size is too big. So I get this the lower than the default mode. Yeah, I'm gonna adjust the damping right here. And I'm gonna make this value at 1. Yeah, the first is the recade can be adjusted in damping. So if you say that the falling speed is slow, you can increase the gravity value right here. And I'm gonna add colloid fluid effector again. And adjust the position Y like this. Yeah, I think it's amazing to be able to make a fluid like this in real time. So yes, now let's take a break and 10 minutes and make the fluid system detail through the procedural system.